Welcome to this video. We're going to talk about place values and names of numbers. So, excuse me, we're talking about whole numbers here. So a whole number is a number like the counting numbers, like 0, 1, 2, and so on. They go on forever. They go on and on and on. Okay. Once we get past 9, right? If we keep going, we'll get to 9. The next number is 10, right? So 10 is a number that is composed of 2 digits. And those digits, when we're talking about our numbers, are just those zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. That's all of our digits. There's 10 of them, including 0, up through 9. And then we just combine them to make bigger numbers. Like 10 has 2 digits, 100 has 3 digits, and so on. Right? So if we have bigger numbers, like say we have 357 is a number composed of 3 digits, a 3, a 5, and a 7. This 3 is worth more than the 5 and the 7 because it's in a different place than the 5 and 7. It's in the hundreds place. So because it's here, it's worth 300. The 5 is in the tens place, it's worth 5 tens or 50, and then the 7 is just in the ones place, right? And so it's this placement system that we'll talk about next. You have to excuse me, I'm kind of getting hoarse here, but we're going to talk about those larger numbers. So let's suppose we have a very large number. Let's say, oh, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's just keep going here. Right? That's a big number, right? So you'll notice that I've separated each of these groupings of 3 by a comma, right? And so our number system that we'll use here has a couple of things about it. First, it's periodic. Each of these little groupings is called a period. Right? A period is something that happens cyclical or with regularity. In this case, every 3. We call that next group, the next period, the next period, the next period. Right? So these periods have names. I'll try to fit them in because some of the names are bigger than I think my groupings will be. But this very first period all the way to the right is the ones period. This next group of 3 over here is called the thousands period. The next one is the millions. And then the next one is the billions. The next here is the trillions. And these numbers just keep going. I can get a bigger number, I can get another period, I can get another one after that, and I can get another one after that, and I can keep going. They have names for these. Trillions are here. The next one would be quadrillions. The next one after that is quintillions, sextillions, septillion, octillion, nonillion, decillion, undecillion, duodecillion, and they just keep going on, right? So they go on forever. We're not going to talk about all those names. You don't need to know anything. Really past trillions is not something you'll encounter quite often. But this is the periods. And inside, what makes it periodic is that each of the 3 digits in each period has a place value in that period. So, for example, this 6 is in the ones place in the ones period. This 5 is in the tens place in the ones period, and then the 4 is in the hundreds place in the ones period. And then it's periodic, so this just repeats. The 3 is in the ones place in the thousands period. So the ones, 2 is in the tens, and 1 is in the thousands. Ran out of room there, but the thousands placed, or sorry, the hundreds, my bad. The hundreds place in the thousands period, right? So any digit, say for example this 5 right here, if we're asked what place value, or in what place value is the 5, this specifically, this 5, not the other one, this 5 is in the tens place in the billions period, so we would say that this is in the 10 billions place. So you just say which place it is in that period, followed by that period. It's in the tens place in the billions period, it's the 10 billions place. Right? This 3 right here is in the ones place in the trillions period. So it is in the 1 trillion place. So that's how it works for all of these except the ones. When we find things in the ones place, we typically tend to not say the period. So this 4 right here, we would simply say that this is in the hundreds place. And by not indicating a period, it's understood that it's in the ones place. Or excuse me, the ones period. So the hundreds is simply the hundreds of the ones period, but we don't say the 1. When I've got a number written in this form, and I'm going to clear this out so we can see a little bit nicer, this next thing. When I have a number written in that form with my periods separated by commas, a number such as this, right? This is in standard form. This is what we call standard form of a number. And it's just the digits of the number written out, of course, from greatest value to smallest value, with periods separated by commas. The digits of a number separated, I think I spelled that wrong, I don't know. The digits of a number separated into their periods by a comma. Well, it's easy to see the ones period here, comma, thousands period, comma, millions period, comma, billions, comma, trillions, so on, so on, so on. So, this 8, excuse me, this 8 right here, what place value is that 8? Well, first we find the period that it's in. The first one's the ones, then the thousands, then the millions. And since it's in the ones place in the millions, this is the 1 millions place. How about this 2? Well, this 2 is in the billions period, and it's in the hundreds place, so it's the 100 billions place. Okay. Now, it's nice to see these types of numbers, right? The standard form written in books and things like that. But if you were to, say, talk to your friend and you had a number that large, it would be kind of inconvenient to listen to somebody speak that number, right? If I had to, I wish I hadn't erased it now, but if I had to say that number to you, or a very large number, let's just write one here. If I had to convey this number to you, I'm just speaking to you, and I said, well, the number is 45682137695, right? It's hard to it's hard to appreciate the magnitude of that number when you just have numbers being basically thrown at you, right? So when we speak, typically we would convert this number into word form, and the word form of a number is you're going to say the number in the period, followed by the name of that period. So for example, this number that we have written up here, I would say as 456, right? And when I'm writing these, sometimes I will write out 456. Most of the time I don't. That's mostly because I just kind of get lazy about the way that I write these. But the actual word form of this would be 456. Right. That's the number in this period, and the period is, well, this is ones, thousands, millions, so billions. So 456 billion. Comma, and then you move on and do the next period. 821. Million, comma, 376, thousand, 925. So when you look at this huge thing that I've just written here, that is the name of this number, you can see why I prefer to shortcut this, because that's a lot of words. But if you're speaking to somebody, this is what I would say. Without even looking at this, to tell you this number, I would say 456 billion, 821 trillion, or sorry, 456 billion, 821 million, 376,925. So notice in the word form, the word and is not there, right? And the reason that I've not written and, despite the fact you may have caught, rewind it if you didn't, because I caught myself saying and. When I said this number here, I said 456, right? The word and can be misinterpreted mathematically because it means plus. So if you say the word and in the middle of your statement, you might be changing the meaning of your statement, right? For example, let me show you a number. If I have this number, and I speak this to you, most of us would recognize if I said 204,000, that I mean this number. But English is one of the few languages that we have the grammatical structure that we do. Other languages, if I said 204,000, they might think that I mean 200 plus 4,000. So 204,000, which if we add these together gives me 4,200, which is not what I meant. I meant 204,000, but I said 200 added to 4,000, right? So it's a little bit of ambiguity can be introduced there by using the word and. So you want to be careful with that. Try to eliminate it from your vocabulary. If you're speaking to somebody else that speaks English, it's probably not going to be a problem. Most people understand the and is limited to adding the 204 together and then the 1,000. But just be aware that that might occur. Okay. All right. So of course we just took a number from standard form and put it into a word form, and we want to be able to go backwards and do it the other way, right? I want to take it, if there's a word form, I want to be able to write it as a standard form number, and that shouldn't be hard because we're just kind of converting in the opposite direction. So if I have a number, say, this one, right? And again, you'll notice that the ones period, I don't actually write ones at the end of the number in the ones period. I didn't do that in the first one. It's not written here. So if there's not a period indicated, again, it's implied that you're back in the ones period. So to write this number as a standard form number, I have a number, 564, and then it's period. So 564 is just a 564. It's in the thousands, so I know that I have more numbers to come. 3 more. What are those? Well, it's 318. So 318. And that's my number in standard form. Okay? There are a few words that you may come across that you have to be careful with. $25 million, 8. Well, I know that I have 25 million. So 25 is my number inside the millions period. I know since it's in the millions that I have a bunch of more digits to come. The next one is just an 8. So don't come in here and just throw an 8 and call it good, because this is not 25 million 8. This is 25,008. There's a whole period here that is not listed in the word form, so that is a 0. It's a bunch of zeros in that entire period. So you need to zero fill any period that is not explicitly listed out in your word form. So now I have 25. My thousands period, since there's nothing there, is all zeros, and I have 8, and so it's 25 million 8 this way. Okay. And then one more form that we'll talk about here is extended form. The extended form let's take a look at a number. Let's say we have 35,273. So, excuse me. Each one of these places, right, this 3 right here, the 3 is worth 3 10,000s because it's in the 10,000s place. The next digit, the 5, is worth 5,000 because it's in the thousands place. So I'll write that as just 5, and then its entire place value name, which is just the 1,000s place. And I keep going through 2, this is in the hundreds place, so I'll just write 2 hundreds. And I have 7 in the tens, so I have 7 tens. And then 3 in the ones. Excuse me. Right. So I've just listed out each of the numbers and essentially their place values. Right? And if I put a plus, that is the representation of what this number means. It's 3 10,000s plus 5 more thousands plus 2 more hundreds plus 7 more tens and then plus 3 more ones, right? And so that is the extended form. I would write this kind of left to right if I had a lot more room. I'll do the next one like that, but this is the extended form, is simply to write each digit followed by its full place value. And then throw a plus between them all. Let's take a look at one more here. Let's look at 14,206,192 is the word form of this. But I want the extended form, so I'm going to write that there is 1 10 million plus 4 million plus 2 more 100,000s plus, there's nothing in the 10,000, so I don't have to write it. I just move on to 6 thousands plus 100 plus 9 tens and then plus 2 ones. Once again, it becomes a very large, especially if you start with a large number. The application here is basically just conceptual, just to understand that this is what we mean when we write a huge number with all these digits, is that I have this amount plus that much more plus a little bit more. That's what having these place values means. Okay. All right, that's it for this video. Thank you, and I'll see you for the next one.